We can hear you now. Thank you.
Fantastic. Wonderful.
All right.
Everyone.
Okay, so I'll go ahead and since I'm in person, like I said, so we just witnessed here a little bit of some of the challenges that you'd face and why lean engineering and lean testing is something that we might want to explore. And we're going to go into a bit of this and what we're talking about here. So our whole point is that. So yeah, so we want to talk about lean testing, 10 minutes of the good parts. So one of the key things to understand when we're talking about what lean testing is, lean testing comes from lean engineering. And let's just get a show of hands. When I say lean engineering, who understands what that means? A few hands, okay? Good, so this is something that's a fairly new topic to some people. Thank goodness. Otherwise, I was probably gonna bore a whole bunch of you with this. So lean engineering is a discipline that basically came about because of the end of World War II. And also it came about because the United States had no use for it. And I need to set the preamble for why that's the case. Many people here probably have parents, grandparents, those who served during World War II on many of the sides of the conflict that happened there. And if you happened to have lived in Europe during the 1940s, most of the European infrastructure got completely destroyed. If you lived in the United States, most of the infrastructure was pristine and never damaged. Yes, the materials that we sent over there got bombed and shot up, but our factories and the ability of creating things and having just all the processes and all the resources to do that were always there. More to the point, after World War II ended, what you had was Europe was bombed out and destroyed, needed to be rebuilt, literally. And America was the one building everything for them. So they were going gangbusters. They were literally pushing things out the door faster than they could humanly do it. And the money was rolling, and it did for decades. So the whole idea of saying, hey, we would like to see us maybe do more with less and be able to have a more efficient process. They didn't care about efficiencies. They didn't need to. They were able to just keep rolling as long as the good times were good. That leads us to a third part of World War II, which had an interesting challenge here, and that was Japan. Japan, yes, also had a significant amount of damage, but nowhere near the damage that Europe had because of the back and forth and the way the battlefields were just destroyed. Certain parts of Japan, yes, because of the nuclear bombs of Hiroshima and Nagasaki, absolutely devastating. But much of Japan's infrastructure, especially in the northern part of the country, was intact. What they didn't have was resources, at least nowhere near the resources that the United States had. And so when they were trying to get their manufacturing base up and running, people like Deming and Jurin, who were talking about things like efficiency and being able to make things work cleaner and more effectively and more efficiently, were actually listened to, because they thought, we're going to have a struggle with the amount of people that we have, the small island that we have, and the resource challenges. So doing more with less seems like a really good idea to us. Sorry, let me advance slide here. Sorry. Is it? There we go. Yes, let's get that out of here. Sorry. Go. Disappear. So again, the key point here is with lean is to do more with less. And a lot of what ended up happening with the changes in and understanding of trying to do more with less and being able to be efficient and work with just-in-time capabilities and all that went with that. Japan did not know, and I'm using this to be kind of humorous, but it's true, they didn't know that Deming and Jurin were looked at as the weirdos. They were the strange ones. They had these strange ideas. Why do we care about efficiencies when we're making money hand over fist? In about 15 years, they were going to be speaking a very different tune. Because for anybody who paid attention during if there was anybody who paid attention during the 1940s, it was this man that is on the next slide that I will be showing you. So a quick question. I mean, I say it, but anybody show of hands. Who knows who this man is? I see a couple of hands. Okay. This is Taiichi Ohno. Taiichi Ohno is, well, famous, especially in the lean engineering world. He's the man who defined the Toyota production system. Okay, show of hands. How many people here know what Toyota is? Okay, good. There we go. Now we're talking. Toyota did something very revolutionary in the 1940s and 1950s. For those who are, if you're willing to admit your age, and if you're not, that's okay, or if you have parents, you might have remembered that at one point in time, Japan was known for fairly cheap quality, low-end products, but they were very affordable, right? Toyota did something very different with that. They said, let's see if we can actually, again, doing more with less, how can we use that to our advantage? How can we, with less of the resources that we have, how can we actually make better products, make more reliable products, make products faster, make products more efficiently? And can we, with that, actually benefit from it? And so Taiichi Ohno and the Toyota production system revolutionized the marketplace. Things like just-in-time inventory, the Kanban system that you use in software today. Who knows what a Kanban is, by the way? Okay, a few people. Who knows where the word originated? Michael.
Yeah, so isn't that in a production system where listing thing that is currently being built?
Yes. Kanban is a ticket. And basically, it's the movement of the ticket that matters. And that's where the whole idea of Kanban came from. And it's also where just-in-time inventory, instead of having all this stuff in place, you're able to do much more with it. Now, one of the key things that he focused on that Taiichi Ohno looked at, the word is muda, which translates kind of to waste. And the key thing for being able to focus on lean engineering and on lean testing is to focus on how to eliminate or minimize wastes. And he had 7 wastes. And all those 7 wastes, by the way, are relevant to software as well. So you have non-quality. In other words, defects. Anytime you have a defect, that is a waste, literally. You need to be able to work with it, fix it, get going with it, and bring it back into production. Every time you have a defect, you have to stop, fix the defect, and then go again. So anything that you can do to either address the defect beforehand or take it out of the system entirely and work on it so that the next time it rolls through, you don't have to worry about it, that's going to save you that waste. Overproduction. There's a acronym, YAGNI. You ain't going to need it. If you overproduce something to where nobody's really going to benefit it, it's a waste. It's not doing you anything. In fact, it's costing you money, time, and attention. Waiting. Having to wait for something. Anytime you do work and anytime you say, hey, I've passed this off and now somebody has to work on it and you are just sitting idle because you can't do anything, that's a waste. Being able to break up the work so that if somebody has to work on something, you still have work that you can do, helps to eliminate that. Transportation, or in this case, movement, right? If I have to go and get something from the other room, a tool, and then come back here to do the work, and then I have to go back and put it in the other room and come back, that movement back and forth is wasted time, effort, and energy. Having the tools I need next to me, near me, that I'm able to work with rapidly is going to help eliminate that particular waste. excess inventory. Now, of course, there's not a perfect here. If you have just-in-time inventory, that is fantastic to be able to make sure that you don't have to worry about a big buildup of things that don't get used. But the disadvantage of just-in-time inventory is if you get overwhelmed, you then have a deficit and you have to build back up to that. Ideally, just-in-time inventory is anticipating your needs. Motion. If you have to do a lot of extra movement, this is one of those things I like to think about when you're in the gym. If you're trying to lift heavy weights, one of the things you don't want to do is you do not want to do these big radical twists and turns and contortions. You want to be smooth, you want to be direct, and you want to flow in one straight line. Motion excess is waste, and being able to get rid of that or minimize that will help. Again, it's one of the reasons why when you look at modern assembly lines, very little movement has to be done at any given place to be able to get from one thing to another. And then, interestingly enough, excess processing. Going back again to overproduction, excess processing is you can actually over-engineer. You can over-produce the quality that your system has. And that in itself is also a problem. Because again, it comes down to you don't necessarily need it. And if your customers are not going to notice the difference in that overabundant quality, who does it benefit? It really doesn't. So with that, I'm going to turn over, and I hope we'll be able to hear it. Matt, can you
hear me now? Can you hear me
Yes.
now?
Yes, you're on.
Okay, fantastic. Couple things. So we want to do with this talk is give the audience, you can actually go get a piece of paper over a lunch hour, come up with ideas to improve the way you're doing software delivery. And the 7 ways is a quick go through, what am I doing that just is non-value add? And it's the value add is the perception of the team as the people that are doing the work. So when I was at Press Ganey in South Bend, Indiana, we'd have a Tuesday meeting where we would walk maybe half a block to a meeting on the other end of campus. And the whole team would go. And while we were going, we would talk about stuff or think about things. And then we would come back and we would come back refreshed. We didn't see that as waste because it accelerated our performance. There were other organizations I've worked with where you'd get interrupted all the time and have to physically walk to meetings all over the building, and it was waste. So it's really the perception that's important. You don't want someone external with a stopwatch checking these things and saying, "Oh, you're moving your hands a lot. That's waste." Well, maybe my hands are getting tired. So once we've gone through the 7 ways, we can talk about 2 more things today, particularly lead time and cycle time. Lead time being the time from when we identify the work needs to be done to when we actually do it. Or start doing it. No, I think it's that's interesting. That says it's from when typically I say lead time is from ticket creator to start of work. We could debate it, but I've worked with several organizations that it's usually requirements, and it's usually a year or 2. It's a product roadmap, and I mean detailed and actionable. I'm fine with we've got some high level goals and things, and we kind of know whether they're bigger than a bread box, and kind of have them measured so we can compare them and look at ROI. But I'm talking about we could do it right now. We could pick this up and do it tomorrow. I worked with an organization, like I said, one organization had 18 months of this work stacked up. It's inventory, it's invisible, we can't see it, and we think it doesn't count because it's in SharePoint or it's in Jira or something like that. But the reality was 18 months later, the stuff at the bottom got stale, it got out of date, we didn't do it. And even if we wanted to, the person who wrote it had transferred or moved on, or there'd be new priority stuff that would come in, we'd never get to it. That's waste. So let's move on to cycle time, which is really what I want to nail today. Lead time is important, but cycle time is the thing that if you're a technical contributor or in an architect role, you could probably just improve right now. And that is the time from when we start work to when a ticket is live. And the particular thing I want to talk about is actually just the cycle time of the delivery process. So from the time the developer pushes the code to version control, the developer thinks they are done, to the point the code is on production. How much time elapses? Now, in many of the organizations we work with that are doing continuous integration, continuous delivery, they got it all figured out. They can deploy individual pieces. Great. How long does it take you to deploy? The executives will think that we are living the book. Humble and Farley wrote the book Continuous Delivery. It's on my shelf somewhere. The executives think that it's the same day, but it's not, because when the programmer finishes their work, it's got to be tested, which is fine, but we have work in progress, so the tester can't start it today. They're going to start it the day after tomorrow. They find a bug, the developer has to fix it, go back and forth. That process, which in real time is actually only about 3-4 hours, is actually spread out over 3, 4, 5 days. Then you have, okay, it's done, tested, it needs code review. Frequently, code review is after test. Well, we need to find someone to do the code review. Okay, we wait. How long does that process take? Code review is done. What now? Oh, now it runs the CI/CD cycle. It passed everything. Sometimes it doesn't. You got to go back and do it over again. You could measure and aggregate that. Great. Okay, now it can go to prod. Wait a minute. Let's see here. Did we merge it yet? No, we need to merge it into the main line. Merge it into the main line. How often are there failures where the merge fails? More than 0. Okay, now we have to run CI/CD again. How often does that pass? Less than 100%. Okay, now it can go to production. So if we actually just spent 2 weeks measuring the actual cycle time, we might spend 5, 6, 7 business days. Now, the book has the math. The short answer is the longer that cycle time is, the more you're going to slow down throughput. But it's invisible, so we don't notice. So measure cycle time, and then measure cycle time, and then sorry, someone from PNSQC is pinging me. Measure cycle time, identify your opportunities for improvement. When you're asked why are things taking so long, it's because our average cycle time is 7 days. If you can do something about it, you can fix it. If they can't, 2 months later, 6 months later, why is it taking so long? Well, I told you cycle time was long. We didn't do anything about it. That's the thing to measure. I'll be around to talk about it. Everybody can find my LinkedIn. They only gave us 15 minutes, so.
And thank you very much. And so to close this out, again, as I said, I have one copy that if somebody would like to go home with that tonight, and yes, I would be more than happy to sign that copy for them. This is how you can get your own copy. That's a quick URL. If you want to take a picture of that and order it, by all means do so. And yes, if you happen to catch me, and if you see me at an event and you have the book and you want me to sign it, or if you want Matt to sign it, we will absolutely do so. And with that, thank you very much.
Thanks, man.